and outer lip seals. Leave the lip seals on the piston for now, but if you do take them off, lay them next to the piston. You'll need them later on in the rebuilding process to match them up with your new ones. Well, that pretty much does it for the reverse input drum. Now let's move on to the main input drum. To start dismantling the main input drum, first turn the drum over, input shaft down. This is where that hole cutting the table comes in handy. To make it easier to demonstrate the locations of the snap rings in input drum O-ring, I've cut an input drum in half. Since this is a deep drum, it will make it easier for the camera to view their locations and placements. First, let's remove the 3/4 clutch pack, located here. To remove the 3/4 clutches, you'll need to remove the snap ring. The 3/4 snap ring fits in this groove. Remove your snap ring. Then remove your 3/4 pressure plate. Now underneath the pressure plate, you'll find 5 3/4 load springs. Go ahead and remove those now. Next, let's remove the 3/4 clutch pack. Notice at the bottom of the clutch pack, you'll find the 3/4 apply plate. The next pieces to come out is the input sprag, the forward clutch pack, and the snap ring that holds them in the drum. The snap ring fits in this groove, located here. Using a pair of snap ring pliers, lift out the input sprag. And with it will come the forward clutch pressure plate. On late model units, with the sun gear mounted to the input sprag, lift the sprag assembly out by hand, using the sun gear. Let's set the input sprag off to the side for now. This will be our next subsection. We'll dismantle it after we're finished with the input drum. Now underneath the sprag will be another Torrington bearing. And notice the way the Torrington bearing sets in the drum. Then remove the input shaft to output shaft lube seal. Now turn the input drum over and let's drop out the forward and overrun clutch packs. We'll start with the first steel that was in the drum and work our way up. Remember, we just turned the drum over, so these clutch packs are now upside down. The bottom overrun steel and an overrun clutch, another overrun steel and clutch, then the apply plate, and the forward clutch waved plate. Next will be the bottom forward steel and a forward clutch and the rest of the forward clutch pack. There are two clutch packs here combined into one. The overruns, which is used for engine braking, and your forwards, which are used to run your forward gears. Next, you'll need to remove the pistons and their return springs. To do this, you'll need to remove this snap ring located here. We'll use the universal spring compressor, just like we did in the reverse input drum. Just below the snap ring groove on the tower is a ledge. The spring cage will not compress down past this ledge. If you try to force the spring cage down past this ledge, you will distort the spring cage itself. Once you have released the snap ring, remove the return spring. Then, to empty the drum of its pistons and related parts, simply turn the drum over. The first part that went into the input drum is the 3/4 piston. Remember, we turned the drum over, so now the parts are upside down. And next is the 3/4 clutch apply ring. Then the 3/4 clutch spring assembly. And next is the forward clutch housing. Then the forward piston. And last, the overrun piston. You'll also notice on the pistons the inner and outer lip seals. Now remember to match your old lip seals with your new ones. Late model units will have one or all three of its pistons molded or bonded, like this 3/4 piston shown here. This means the lip seals are molded to the piston housing itself and cannot be removed. Now let's go back to the input drum. Looking down inside on the drum tower, you'll notice an O-ring located here. During the rebuilding process, you will need to replace that O-ring. Well, that does it for the teardown of the input drum. Lots of parts, isn't it? Now let's move on to the input sprag and tear it down. But before we dismantle it, take notice of the sprag's rotation. Just like on the low and reverse roller clutch, it will freewheel one direction and lock the opposite direction. To start the teardown on the input sprag, remove this snap ring, then lift off the overrun clutch hub. Once the hub is removed, simply push out the sprag and inner race from the outer race. Then lift off the first retainer ring, and then the sprag element. And next is the second retainer ring. And what's left will be the inner race. To remove the late sun gear from the input sprag, use an old socket and drive the sun gear away from the sprag assembly. Now be careful not to damage the sun gear bushings. And that's it for the input sprag. Not much to it, is there? Well, are you ready for that valve body? It's not as difficult as you may think. Now be careful when handling the valve body. The electrical solenoids are fragile and can break very easily. The valve body webbing can also suffer damage if handled roughly. So be careful and take caution when handling the valve body. First, let's remove the forward clutch accumulator cover by removing these 3 bolts. Now this cover is under strong spring tension, so use caution when removing it. There will be 2 springs underneath this cover: the low overrun valve spring and the forward accumulator spring. Next, remove the forward accumulator guide pin and then the forward accumulator piston. Then remove the low overrun valve. Just like we had on the 1, 2, and 4th accumulator piston. The forward accumulator piston will also have a D-ring located here. Next, let's remove shift solenoid A and shift solenoid B. You will need to remove these two spring clips to separate the solenoids from the valve body. Now be careful with these spring clips. They are springy and easy to lose. Once the clips are removed, the solenoids will simply pull from its bore. Also, the valve lineup behind shift solenoid A is under light spring tension, but nothing like the forward clutch accumulator spring cover. Still take caution when removing this solenoid. Then remove the valve lineup. First will be the 1-2 shift valve. Then using a pick, remove the 1-2 shift valve spring. Be careful not to damage or scratch the valve bore. Then remove shift solenoid B. Unlike shift solenoid A, it is not under spring tension. Its valve lineup is free-floating valves with no springs. The valves should be free enough to fall from the bore. If not, then you'll need to work them through the valve body. You can use either side of the valve body to do this. This may be a little difficult at first, so take your time. You don't want to damage the valves or the valve body webbing or any of the ports. I'll demonstrate this for you. Using one of your picks, working through the valve body webbing, push the 2-3 shuttle valve from its bore. Remove the 2-3 shift valve the same way. Simply work it up through the bore between the webbing and the ports. And remember, don't scratch the bores or the valves. Next, remove the pressure control solenoid by removing this retaining bolt and bracket. Some technicians will call this a force motor. Nevertheless, it removes the same way as the shift solenoids did. It simply pulls from the bore. Now going to the top side of the valve body, let's remove the 3-2 control solenoid. It is also held in by a spring clip located in this slot. And it removes the same way as the other solenoids did. It pulls straight from the bore. 1995 and later models will use a 3-2 control valve lineup like this and is under light spring tension. See, I told you the valve body wasn't all that hard. I know we didn't remove all the valves, but do we need to? Do they really need servicing? For now, let's just properly clean the valve body in the cleaning process part of this video, and then during the rebuilding process, we'll deal with the rest of these valves. It's a whole lot easier to inspect the valves' movements and their bores clean than in a dirty and unclean environment. Now, the best tools for inspecting transmission parts are sight, feel and touch, and just plain common sense. Hey, it's simple. When in doubt, throw it out. We'll start the inspection process with the pressure plates and steels. You're looking for any discoloration or hot spots on the face of the steels and plates. If there are any, then they are unusable and must be replaced. Now, if any of the clutch packs are welded together, obviously they're trash, pressure plate and all. Also, Check to see if any of the steels are warped. Taking the pressure plate from the clutch pack, rest each steel on top of the plate. Do not use any steels that are convexed or concaved. They should be completely flat, except for the cushion steels, and they're designed that way. Now, late model units will have lube holes cut into the reverse input steels and the low and reverse steels. That's okay, they're designed that way. Now make sure your rotor guide and plastic washers still have their tabs and are not burnt or melted, or have any metal embedded into them. Check all of your Torrington bearings. First, clean them up good in solvent. We'll get more into solvent cleaning during the cleaning process. Roll the inner and outer races against the rollers sandwiched between the races. If the bearing feels rough and not smooth, it's trash and needs to be replaced. If your transmission uses the metal 4-tang washer, make sure the surface is smooth and it still has the brass coating, making sure it has all 4 tabs. Check all 3 accumulator pistons for cracks, and look at the guide pin bore for any wear. Now the pin should move in the bore without side-to-side movement. Check the guide pins for any wear. If you have any pistons that are made of plastic, it's a good idea to upgrade to the aluminum style. Check all the clutch drum pistons for any cracks or damage. Check the overrun and forward pistons, release check ball. By shaking the piston, the ball should rattle. If you have molded pistons, then make sure the rubber is soft. Check the release ball in the forward clutch housing. Also, check the area where the lip seals ride. The surface should be smooth. Make sure all the release springs and cages are in good condition. The cage is flat and not bent, and all the springs are attached. Check all your return springs, make sure they're not cracked or broken. All the snap rings should retain their strength, and of course not broken. Next, look over all the bushing surfaces throughout the entire transmission. The bushings must have minimal wear and no pitting or riding off to one side. Notice this bushing at the end of this stator. This bushing is not acceptable and must be replaced. The bushing in this stator support is still in good working condition. Now pay close attention to these 2 stator bushings. The bottom bushing stabilizes the turbine shaft rings and helps seal them, and the top bushing stabilizes lockup pressures. If this bushing is bad, it will slowly burn up your torque converter. At the end of the inspection process, I will replace this bushing and show you how it's done. One of the keys to a good transmission overhaul is tight fit bushings. Now where there's a bushing, there's a part that mated to that bushing. The section of the part that mates to the bushing should be smooth to the touch and without any pits or grooves. If you have a bad bushing, you can rest assured that the part that rides against it is bad also. Like this input shaft, it's bad on both ends and is not a usable part. Or this top ring gear hub, or it's technically called the reaction carrier shaft. Nor this bottom ring gear hub, or technically called the internal reaction gear support. Both these ring gear hubs are bad and need replacing. Now to separate the top and bottom hubs from the internal ring gears, remove the snap ring located here. Now let's start with the pump and stator and work our way down through the transmission. Now if your pump looks anything like this, you can bet that every part that makes up the pump will be trashed, including the pump body. If the pump assembly is bad, then the pump cover will be bad also. Now check the surface area on the pump cover, where the pumps slide and the rotor and vanes ride. The surface area must be completely smooth with no grooves. Check the two bushing surfaces. They should be smooth with no grooves. Now look down into the stator shaft where the 4 input shaft sealing rings ride. The inside should be completely smooth, like this one showing here, with no ring grooves, except for the oil delivery holes. The inside of this stator support is completely bad and will need to be replaced. Now check the splines. They should be in good condition. Now the stator support will separate from the pump cover. First, you will need to remove these 3 bolts. The stator support is pressed in at the factory, and to remove it, you will need a good sized press. Check the 2 bushings. Make sure the check ball and orifice is in good condition. The ball should be loose in the orifice, just like on the forward and overrun pistons. Now make sure the pressure relief ball and spring is in place. They're held in place by this rivet. Now let's inspect the reverse input drum. First, let's check the band surface. To do this, you will need a straight edge. Now lay the straight edge across the band area. This area must be completely flat, like this drum here. Now if you see any gaps between the straight edge and the drum, then the drum is bad and you will need to purchase a new one. The 2/4 band area of the drum must be completely flat with no hot spots or scoring. Check the 2 bushings and check the area where the 2 sealing rings ride. The cylinder must be smooth with no grooves, like on the stator. Inspect the area where the plastic 2-tab thrust washer rides. Check the teeth and snap ring groove for any damage that might have been caused by bad steels and friction plates. Now checking the input drum, inspect the entire drum and shaft for any cracks. Check the teeth where the reverse input clutch is splined. If they look anything like this,